introduction of this subject, its content, its teaching methodology, examinations, prerequisites, outcome, etc. Now we'll start with the introduction part of power electronics. So basically, you have to know what is power electronics. So power electronics provides conversion of continuous, that means stepless, with a high efficiency of physical quantities. So what are the physical quantities? Voltage, current, power, etc. Now, not only the power electronics provides conversion that is static without moving parts with high efficiency, that is by power semiconductors, the diode, transistors, etc., which we will study later on. And then what does it mean? So power electronics is means, so it is power electronics is a conversion of power electronics provides conversion of continuous with high efficiency physical quantities, that is voltage, current, power, etc. And of course it is with static and high efficiency with the help of power semiconductors like diodes, transistors, etc. And what are its applications? So power electronics applications is the conversions of voltage, currents, frequencies, compensations of disturbances, that is voltage fluctuations, etc. Reduction of tolerances, that is improved use of material and design, control of facilities and equipment. So in a nutshell, if we see it will be clear from this diagram. So it is say if these are the power electronics devices, that is converters, it is a converter, suppose. So if it is input and output frequency being same of AC, so output frequency equal, so it is a power controller, AC power controller. Now if from AC to DC it is being conversion is happened, so it is rectified, or from DC to DC, that is from one type of DC to another type of DC, fixed DC to variable DC. So this is a DC-DC converter or chopper controller. And another thing is from DC to AC, so that is from this inverter. So these are all about this applications of the power electronics. And now this applications is not only limited, so it is widely used from simple from watt to megawatt. So that is from lighting a simple lamp to a high voltage DC transmission, etc. So nowadays power electronics applications is not limited. Everywhere it is you can use, and it is being used, starting from aerospace, engineering or aerospace. There is space shuttle power supplies, satellite power supplies, aircraft power systems, etc. In the field of commercial field, that is advertising, heating, air conditioning, central refrigeration, computer and office equipment, uninterruptible power supply UPS, light dimmers, flashers. So all these commercial applications are possible with the help of power electronics. In the industrial, there is arc and industrial furnaces, blowers, fans, pumps, compressors, industrial lasers, transformer tap changers, rolling mills, textile mills, excavators, cement mills, welding. Everywhere in the industry, power electricity is being used. In residential, also air conditioning, cooking, lighting, space heating, refrigeration, electric door openers, dryers, fans, personal computers, other entertainment equipment, vacuum cleaners, washing and washing machine, light dimmers, food mixers, electric blankets, food warmer trays. All in the residential purposes, also power electricity is being used. In telecommunications sector, there also power electricity is highly used. That is battery chargers, power supplies from DC and UPS. In transportation system also, it is battery chargers, traction control of electric vehicles, electric locomotives, street cars, trolley buses, subways, automatic electronics, all everywhere power electricity is being used. So utility system, as I told you, it's in HVDC systems, excitation systems of the generators, power compensation, voltage reactive compensation, static circuit breakers, fans, boiler feed pumps, supplementary energy systems, solar, wind, etc. Everywhere actually nowadays we are applying power electronics and its power electronics control devices. So application area or field of application for power electronics is enormous. So that's all about the applications. With this, now we will talk about the controlled converters, uncontrolled converters. The name itself suggests that converters, whatever it converts, it can't controls. That means it doesn't have the control over the output. That means basically we whenever we convert AC to DC, it is a rectifier, and since rectifier is particularly using the diode, PNs and diode, so it doesn't have any control activities. That's why it is diode using center tap rectifier circuit. So AC input is the center tap to diode system. So this is the DC output. So center tap configuration is dealing with this two diodes. Center tap transformers is getting DC. That is, you can't control. You can't say don't have any control over this DC output. So that's why this is called uncontrolled converters. Now, if instead of diodes, if we are using AC as a thyristors to convert AC to DC, we can get a control output. So that's why it is called controlled rectifier output. But like diodes, AC does not become conducting immediately after this voltage will become positive. So it requires triggering by means of gate pulse signals, definitely. So it is possible to make a thyristor conducting at any point on the half-wave quiz that is positive voltage with anode. That's how it is controlled. Now, what is the advantages and disadvantages of power electronic converters? So power electronic converters is tremendous growth in recent times, and almost all applications today use power electronic devices in some or in the other form. As it becomes essential to study the advantages of these devices, which made it so popular. So we are advantages and disadvantages of power electronic converters are we have listed here. We have listed. So power electronic converters has the following advantages. This is mass production, huge development in the production techniques of semiconductor devices. These semiconductor-based power electronics devices are now produced in huge and in bulk, and hence resulted into very low price. These devices are available in a variety of voltage and current rating. So one can easily choose from it as per its needs or requirement. So reliability is very high. So devices have no mechanical moving parts. As I told you in the first introductory concept is just like a device. So there are very less failure chances and hence very rugged performance and long life. So provided it is available under, of course, in rated conditions. If you exceed the ratings, that means you are forcefully making it liable for damage. So reliability depends on, of course, within the limits, within the specifications, within the ratings itself. Now efficiency, it is highly efficient. Most applications of this device actually switch, and in both the modes of the switch, that is on and off, the power loss in it is very less, and the switching losses are also very low. And one more thing must be worthwhile to say discuss. There is a maintenance part. Every device, every equipment must have a maintenance part. So that power electronics is a very low maintainable equipment or device. The maintenance is almost negligible. So due to absence of mechanical moving parts, the power electronic systems require almost nil maintenance. The device comparison to mechanical or electromechanical devices, the power electronic systems have a faster dynamic response. So it's a very fast response device. And size, of course, power electronic systems are very small in size compared to mechanical systems for similar product things, and hence less weight, less floor space, less handling issues, less installation cost, less packing and transmission price, and many more. So these are the very important advantages of the power electronics converters. So you can produce in bulk due to improved production techniques. As a result, the cost is lower, the reliability is very high, efficiency is very high, maintenance is negligible, response is very fast, and size is also very small. So transportation, floor space, weight, handling issue, installation cost, packing, etc. Very cost effective. Now these are the advantages, but definitely everything cannot be merit. Everything cannot be advantageous. Some say less or very few disadvantages are also there. So disadvantages of power electronics converters are like this. Definitely harmonics is a big problem. Serious disadvantage of the power electronics systems. Because it injects considerable harmonics at both sides, that is, both the segments to the connected load side and the power source side, supply side. Converters alter the sinusoidal waveform according to the requirement. Harmonics is generated in the output voltage and current of the converters, and also in the input current to converters. So these harmonics create a lot of troubles in both sides. That is, on the load side, if we have motor, harmonic cause problems such as excess heating, more acoustic noise, personal vibration of the motor shaft, commutation issues in DC motors. You know what is the commutation of the DC motors. Since you have already studied in your course and stuff, the commutation process in the DC motors. So commutation issues also coming in using the power electronics devices. Hence, nowadays we have special variable frequency drive motors which are designed to better handle the effects of harmonics. So apart from this, we also have filter circuits to limit the harmonics of the load. On the supply side also, harmonics get a lot of troubles. So the performance of other equipment connected to the same supply is seriously affected. Harmonics supply lines also, the radio interface with communication lines, audio and video equipment. Apart from this, input side transformer also gets overheated and its efficiency gets reduced. Special converter transformer are used when the output has considered power electric systems such as motor types in industries. Harmonics also increases skin effect in the cables and hence motor heating, as you need to install filters in the input side also. So low power factor is also another serious disadvantage. overload capacity is also very less. So another disadvantage of power electronic devices is a low power factor. That is, some certain power electronics converters operate at very low input power factor. So hence it might be required to install reactive power compensation equipment. Another disadvantage is low overload capacity. Power electronic devices work on rated voltage and current provided for proper evacuation system is provided. Excess current causes hotspot at the junction and burning of the devices. So high DVGT leads to false triggering, and hence power electronic devices along with it needs compulsory protection agreements such as snubber circuit is required. So hence, so taking into consideration all these advantages and disadvantages, the cost of overall system increases a bit compared to systems normal motors, transformer, and no filter circuits are used. However, the advantages possessed by power electronic systems are so large and overwhelming that these disadvantages get overshadowed and continuously gaining popularity and exponentially increasing in applications. So that's all about advantages and disadvantages of power electronics devices. Now we will discuss about power electronic systems. So actually, what is power electronics system? The major components of power electronic system, they are shown in this block diagram. So it is a typical power electronic systems block diagram. So main power source maybe AC or DC supply system. The output from the power electronic circuit may be variable DC or AC voltage, or it may be a variable voltage and frequency. And in general, the output of the power electronics converter circuit depends upon the requirements of the load. So suppose if the load is the DC motor, then converter output, of course, will be variable DC or AC voltage, or it may be a variable voltage and frequency. Generally, if it is a DC motor, then output must be adjustable DC voltage. In case the load is a three-phase induction motor, the converter output may be a variable AC voltage with variable frequency. Now the feedback component is measures a parameter of the load. That means it may be a speed in case of rotating machine, and it compares with the command. This we compare with the comments, and then difference between the feedback signal and reference signal or command to the digital circuit components controls the instant of the turn on of the semiconductor devices of forming the solid state power converter system. So that you will learn in your control systems how this error signal between say a load that is feedback signal and the reference of command signals, how this error signal is required for the digital process, and it is useful for the triggering of the power electronics devices, so etc. So that is this is the manner the power electronics converter systems work. So the way of the load circuit can be controlled with this error signals, so as desired over a wide range with the adjustment of the command. Now we'll talk about the power diodes. So you have already studied the PN junction diode, which is ordinary has signal diodes. Basically, it's a junction between p-type and n-type semiconductor, and say lead from joining the p-type is called anode, and the lead joining the n-type is called the cathode. So here is the symbol. This is the anode, and this is cathode. This is p-type. This is n-type. This is depletion region or special region. This is the symbol. So now power diodes also are similar to signal diodes, but have a little difference in its construction. If signal diodes, in signal diodes, doping level of both p and n sides same, and so we get a p-n junction. But in power diodes, we have a junction formed between a heavily doped p positive and a lightly doped n negative layer, which actually grown on a heavily doped n positive layer. And the structures look like this. So actually this is the drift region, anode, and this is the cathode terminal. This n negative layer is the key features of the power diode, which makes it suitable for high power applications. And this layer is very lightly doped and almost intrinsic, hence device is also called pin diode. This I stands for the intrinsic, and from this see, but in this figure we see that net charge neutrality of the space charge region is still maintained as was in case of the signal diode, but the thickness of the space charge region is quite high and deeply penetrated into n negative region. See, now these are the available power diodes in the market. This is like this. So due to this light doping concentration, the thickness of the space charge region increases with decrease in doping concentration. This increased thickness of depletion region or space charge region help us the diode to block larger reverse bias voltage and hence a greater breakdown voltage. So however, adding this n negative layer significantly increases the ohmic resistance of the diode, leading to more heat generation during forward conduction state. So hence power diodes come with various mountings for proper heat dissipation because the heat loss is significant. Now the PI characteristics of power diodes. So this is same almost signal diodes. In the signal diodes for forward burst region, the current increases exponentially, and in power diodes, high forward current leads to high ohmic drop. This dominates exponential growth, and the curve increases almost linearly. The maximum reverse voltage VRRM that can withstand, which is also called the peak inverse regulated voltage or peak reverse regulated voltage. So above this voltage, above this voltage, the reverse current becomes very high abruptly, and as the diode is not designed to dissipate such high amount of heat, it may get destroyed. So this voltage may also be called as peak inverse voltage, as I told you. Now the reverse recovery characteristic of the power diode. This is the reverse recovery characteristic of the power diode. So diode, when it is switched off, current from forward direction to come to zero and further continues in the reverse direction, owing to the charge stored in the space charge region and the semiconductor region. So this reverse current attends a peak IR. This is the peak IR, reverse recovery current, and this reverse current attempts peak and again start approaching zero value, and finally the diode is off after time. This TRR, this time it's off. So this time is defined as the reverse recovery time, and this time between the instant power current reaches 0 and the instant of the reverse current decreases to 25% of the IRR. So, which one? This time. So after this time, there is set to attend its reverse blocking activity. So from this figure, we will find that TRL equal to TA plus TB. T is time when charge from depletion region is removed, and TB is the charge time when charge from the semiconductor region is removed from depletion region. And this is from time removal from the semiconductor region. Also, we know we find from this figure this IR TA didt is equation 1. So didt rate of change of reverse current. So the area bounded by the triangular region in this figure, this triangular region. Okay. So is represent the total charge stored or reverse recovery charge. Hence, this is equal to this area of IR into TRR. Now, if we say TA equal to TRR, so if we put in this equation, then we get the TRR equal to this root over of 2 divided by didt. So this is equation 3. And putting this equation into equation 1 for TA equal to TRR, we get this IR equal to this. So this from equation 3 and 4, you can see that TRR and IR depends on this charge QR, which is interpreted from the initial power that current IR. So another interesting parameter is the power diode from this Turner characteristic known as the softness factor. It is the ratio of TB by TA. That is softness factor equal to unity. It is soft recovery diode. If it is less than unity, it is snappy or recovery diode, or fast or snappy recovery diode. If it and S factor indirectly indicates the voltage tangent that occurs upon the turn of the diode. So low S factor implies high tangent over voltage, and high S factor implies low oscillator reverse voltage. So total power loss during turn off is the product of this diode current and voltage rating, voltage during TRL. Most of the power loss occurs during this TV. So in a typical data set of power diodes, the most important parameter given is average forward current, RMS forward current, repetitive peak reverse repetitive voltage, aspect rating, jump temperature, TRL, soft S factor, IRR. So apart from this, many other parameters and graphs are also available. This can be classified as per the categories, types, it is voltage rating, current rating, reverse recovery, activity, etc. So generally, general purpose voltage rating is from 50 to 5000 volt, current 1 ampere to 7000, reverse recovery within 25 microsecond, used in new phase, literature, transfer, etc. Now, fast recovery diode, again voltage rating between 50 to 3000 volt, 1 ampere to several thousand amperes in the current rating. Reverse recovery time less than 5 microseconds, because in SMPS competition circuit job pass etc. Doping down during using platinum or gold, and then come to Schottky out. This is voltage rating up to 100 volt and current rating up to 300 ampere. Reverse recovery time in in a nanosecond, very high frequency switching power supplies and instrumentation purpose it is used. So the remarks is metal semiconductor junction, usually aluminum silicon N-type, majority period device, and very low turn-up time. So that's all about power diodes. So in this class we learned about the power diodes, its construction, PI characteristics, of reverse recovery characteristics, and of course different types, and